Hello guys, welcome back to SAP video tutorials. In this video tutorial we'll go through wind load analysis on area objects. Like on the last video tutorial we went on frame objects like beams and columns. Today we'll go on area objects like wall. So let me select new model and let's say grid. Okay, that is fine. Looks like we have in inches. So x direction, let me keep it as 15 feet, or should I do it 18 feet? Let's make it 16 feet instead. So 192, this one will be 192, this will be 120, and we'll start from 0, 0, 0. Select OK. Now we have our grid. So what I'm gonna do is I'm gonna define my material first. Let's say I have 5000 psi material. Okay, select OK, and the steel is gonna be the default one that we have in here. So first thing I'll do is section properties, frame sections. I'll add new property, say concrete, say rectangular, and I'll keep it as 18 by 18 for column, 5000 psi. So go to concrete reinforcement, make sure column rectangular and reinforcement to be checked. Number 9, good, everything looks good. These are stirrups, nothing but. Select OK. You can select OK. Next, add another new property for beam. Say it as 15 by 15. 15 by 15, concrete reinforcement. Go to beam and say that top cover is at 2 inches. Yeah, this top cover, let's say it's 1.5 inch actually, 1.5 inch, nothing but. So depends on the code. Select OK. Select OK. Now just use your frame element, say column, go to X, Z, you are on that direction, go from here to here, there to there, there to there, and select beam over here. Oh sorry, F-sec, nothing but I forgot to rename that. Escape. Now select this, go to edit, replicate it in DZ direction, 10 feet. Let's say we have 1, 2, 3. Select 3, select OK. Oh my god. Alright, let me just select that again, go to replicate. Oh, this is 10 inches. No, I need 120 inches. Sorry about that. Select OK. So like that's it. Good. Okay, now we are done with this. Select the whole thing. And how much did I do? 192 inches, right? Yeah, nothing but 16 feet. Select the whole, all the members, go to replicate, and let's see, we are going in negative y direction. So like these are our members at that end and we are going towards this side, so going opposite to the y, so negative y direction. Say this 0, this will be minus 16 feet because I changed the units to feet. And let's say how many numbers do we have? 1, 2, 3. Okay, 3 is fine, as you can see over here. 1, 2, 3. Select OK. So we have our members in there. Now you can just check your model if you want. We need members going in this direction. Alright, fine. Let's go to YZ. Oh my god, not over there. YZ in here. So I can see there are no members in here. Let me just go and put them. Fine. It's simple, just selecting the node points. Make sure that you don't exactly select the node point and it doesn't go and slip somewhere else. Alright, now that you are done with that, just select those members. And as you can see, these are the members, and now you will be going in opposite of X direction. So we'll just go to edit, replicate, 0 in Y, dx will be minus 16. Number of times, 3 times, select OK. So now we have our beams and columns. The next thing I would want is slab element. So let me go and define section property area sections and say add new section, shell thick 5000 psi. I'll keep it as 12 inches, 2 layers, and to 1.5. These are nothing but cover for the steel. Select OK now. Select OK now. Okay, just make this a slab. We don't want to get confused. It is better you change it. Okay, select OK. Now add one more section. Add one more section and say shell thick. Use even 5000 psi. Make it as 8 inches instead of 6 or 12. Modify shell parameters, 2 layers, same as usual. So always, like guys, make sure that you enter your correct data, because in the last 2 video tutorials I made some mistakes, and kind of like in the RCC building video tutorial I entered loads in kps. Instead I should have entered in pounds, and I got deflections like 600 inches, which scared me, and I was like where I was wrong. But later on I figured it out, and it was in the load. I mentioned it in the next video tutorial. Again, in the next video tutorial, while doing the wind load analysis for frames, in Y direction, instead of selecting frames, I selected rigid diaphragm, so that didn't give me proper results, so I had to like rectify it. So yeah, just make sure that you are giving right information all the time. So that is done. Now you'll just need to draw your area section. Okay, that is good. Let me go to 3D view. On 3D view, let me do extrude view. Select OK. So, you see, the slab property is in inches. I need to give it in 12 inches, but since you see the units were in feet, it went to 12 feet. So let me just go to define section properties and say area sections. Let's go to slab, modify section, say it as 1 feet, select OK, select OK, and it should be modified for you. There you go. We'll change this to inches. Alright, now let me just select this. Oh, before that I even need to make change for wall. There you go. That is 8 inches. We don't want an 8 feet wall. Is that all? It should be. Oh my god. This is 2 inches. 1.5. 2 inches. 1.5. Select OK. See, stuff like this kind of scares us when we see the results. Alright, select OK. Now just select this slab and say replicate. Now this will be in negative z direction, so minus 120 inches. Select OK. How many we have? 1, 2, 3. Yeah, fine. That's it. Okay guys, so now in the main reason for this video tutorial will be the wind load analysis for area sections. So I am gonna have a wall over here and on the opposite side. So let me go to XZ. Okay, so that would mean I'm having wind load in X direction anyways. Let me go to area, tool, select wall, draw your wall. Oh, we don't want that. Control Z. Okay, now let me just check it. Where did I? What's wrong with this? Okay, section name is slab. Looks fine to me. Let me just see. Do I have any? I just want to make sure that I do not have any wall sections. I have no idea where did I make those then. Alright, anyways, let me go to XZ. No, I want 3D over there. I want XZ in here. So I am gonna draw the wall. And just come to this and draw it again. Alright. Now you see we have a wall over there, even this side. So that should be good. Let me just go to define and see something for myself. Okay, the display color is green, but why I'm getting the pink? Alright, never mind. Okay, coming to the point of the tutorial, I am gonna apply the area wind load on this walls and on the walls on the other side. So let me just, oh wait, do not play with me. Alright, so this, oh my god, my mouse is so sensitive. So this will be my windward side, nothing but my positive y direction, and the other side will be my leeward side, nothing but my negative y direction. Anyways, so let me just go to define, say load patterns, say wind w in y direction, and I'll say type as wind. I'll give auto lateral load pattern ASCE 710, and I'll select add new load pattern. I'll modify the lateral load pattern. Now in this, so you need to make sure that you select exposure from frame and area objects, and in this you need to select include area objects. This is very important, guys, because if you include frame objects and it will give you completely different results. So include area objects, my wind speed will be 115 mph, my exposure type is B, fine. I have this building in somewhere in between a city, that is good for me, so that is why it's B, and the other remaining will be constant. This, I mean, it might change, but you need to see the code for that. And I want the exposure height to be program calculated, like, I mean, the wind loads will be like less at the bottom levels and will be high at top levels. That will be automatically calculated by my SAP. Alright, select OK. I'll select OK. Now let me tell you, so you see this windward coefficient CP that we need to apply to this area sections before we do the analysis for the area objects. So let me select OK this and OK over here, and let me select the, oh shit, select the walls, dude, oh my god. Alright, okay, I selected the walls. I'll go to assign, I'll say area loads, I'll go to wind pressure coefficients. In this I'll select my WY, and so this is windward side, so I'll select windward, press varies over height, yes, I'll say 0.8, I'll select OK. Now if you select that and give it a right click, you should be able to see in loads that your global component is applied. But one more thing I need to tell you is, let me just go on there, and I do not want extrude for now, and also I'll turn on local access for my area sections. I'll select OK. So the CP coefficient generally acts in local 3-axis direction. So now in order to make for it to act in y direction, I need to instead of selecting 0.8, I need to enter -0.8. Did I select the 4 walls? Yes, I did. So I'll go to Assign. I'll go to Area Loads. I'll say Wind Pressure Coefficients. I'll say minus 0.8 because I need it in Y direction. And the CP, which generally acts in local axis direction, like I say this blue arrow, it acts in that direction. So if you say positive 0.8, it will be acting in this direction, but we want in Y direction on the other side, so I'm saying minus 0.8. Now let me turn over to the other side and select the walls. Oh. Okay, go to Assign, Area Loads, Wind Pressure Coefficients. So other, this will be nothing but your leeward side, and say it as 0.5. Select OK. Now you can just see in loads if you want, you will have 0.5. And if you see for this, you should be able to see in loads your component 0.8. Select OK. Now, yeah, we need one more thing. Oh, supports. I forgot completely. Let's say select all the bottom nodes. Okay, let me go towards the right. That way I'll just only select the nodes and not the columns. Go to Assign, say Joints, Restraints, and I'll keep Pinned because I don't want my movements to be transferred to the column in this case. So I'll select Pinned, I'll select OK. That is good. Now the only thing remained is Analysis. So I'll go to Analyze, Run Analysis. I'll select Run now. Yeah, I need to save my file. Wind Analysis on Area Objects. Select Save. Now the analysis will run. And as you can see, the deformed shape being formed. And if you want to see an animation, you say Start Animation. So I think this is for the dead load. Let me just go in here, say Show Deformed Shape, select WY, select OK. Now I'll say Start Animation. So as you can see, my structure moving here and there. Oh, I'm wondering why I'm not getting my TeamViewer sound. Oh, there you go. So that is my animation. I can decrease the speed. I'll say stop animation for now. Now I'll go in here and I'll say draw displacement contours. Let's see, we have in Y direction, so let me say UY and select OK. Now as you can see, the deflection like in UY direction. Okay, let me just, so as you can see over here we have 0.04, and if you go down it decreases 0.038, and it decreases more, and then it decreases little more. So your deflection in y direction, it decreases from top of the building to the bottom of the building because the wind load acting is very much high at top of the building when compared to bottom of the building. Next you can see your shells. These are your force and moment shear components, all those. But I would like to look into concrete design and the design component, top face, select OK. Now you can see the design components. So let me just go ahead and start the design. So as you can see, the lot of beams are failing. I mean, let's select this one for instance, and you see alright, I think so. Let me try something. Display design info, say beam column capacity ratios. Okay, so you see NA. So those are the ones which are not sufficient for this. Okay, so like you can even generate a report if you want, but before that let me just unlock it and increase the size of the columns and also the beams. Go to frame sections, column, modify or show property. I have 18 by 18, let me make it 24, actually 28 by 24. Select OK. For beam I'll say modify property, make it 24 by 18. Select OK, select OK. Now you just run the analysis and see if it passes now or not. Once the analysis is done, just select this Start Concrete Design button. And go to Display Design Info. Select your interaction ratios. Okay, I need to select this. Okay, so as you can see right now it's 0.036, whereas my beams, they are all in red, which means they are greater than 1. So I mean basically we should be able to see our ratio in here. Anyways, let me just select a column instead. So you can see capacity ratios. If it passes, then it passes. If it doesn't, then it's failing and it's not showing. Alright, anyways, that is fine. Do we have anywhere any of the beam passing? Not one beam. Okay. So the ones which are failing doesn't show the um, capacity ratios, but let me go and try something else and define section properties, frame sections. I'll modify this property. I'll go to concrete reinforcement. I'll select that. I'll select reinforcement with checked. Select OK. Select OK. Select OK. Now I'll run it. Alright, now the design part looks good. Yes. See, some of the beams have passed at the bottom and showing the capacity ratios, but there are some other beams which are failing. And yes guys, like, I mean, again, everything depends on the variables that you apply in the structure, like thickness of the wall, a slab, and the loads you give and the wind loads that are acting on it. So based on that, you just need to make sure that you apply the correct sizes. Alright, so in this video tutorial we learned how to do the wind load analysis on area objects. If you have any questions, please comment below and subscribe. Thank you for watching the video, guys.